So let's see, finish this paper that we started. We ended on question 2C. Okay, ended on question 2C. So the question is saying a board of mass 5 kg is attached to a string 2 meters long and moves in a horizontal circle of radius 50 centimeters. So we are told, we are given this diagram. This is a pendulum, and then we are told that the length, this is a bob which has a mass. So the length of this string is 2 meters. So we are told that length equals to 2 meters. So this is from circular motion, and the radius, we are told that radius equals to 50 centimeters. But if you convert, make sure that radius is in meters, it's going to give you 0.5 meters like that. Now the question is, find the tension in the string. So this is a string of length 2 meters. So remember, tension is always a pulling force. So in this string, there is tension. So to find tension, we are going to resolve all the forces. We are going to focus on this object, the bob. So this is the bob. So now, focusing on this bob, we are going to identify all forces exerted on the bob. So number one force we have is the weight, which is given by mg. The other force, it's since this is a conical pendulum, so it's making a horizontal circle. Yeah. So there is also a force. So this is the center of the horizontal circle. So there is a force that is pulling this bob towards the center. There's also this force that's pulling the bob away from the center. Now let's first resolve the tension here, because we know that here we have angle theta. So let's resolve this tension. So when you resolve, we are going to have something like this and that. So we've resolved the tension. We have resolved the tension. So now, it means if the angle is here, it means this is the angle. So alternate angles are equal. So here we have the theta. So the side that is cut is this. So it's going to carry c cos theta. Then this side that is not cut is going to carry c sin theta. Now remember, this is c sin theta is the force that is trying to pull this bob towards the center. So now, just to support this bob, this c sin theta, we are going to include the centripetal force provided by the centripetal acceleration. So now these are the forces that we have. Now next we are going to assume that it is in equilibrium. Yeah. So meaning the upward force equals to the downward force. Also here, the right force equals to the left force. So we are going to equate the forces in the y and forces in the x. So we are going to have t cos theta equals to mg. Then this is the forces in the x. Now forces in the y, we are going to have centripetal force equals to t sin theta. This is the force in the y. Now remember, the first question was find the tension. So we can find tension from these forces in the x. We can find tension in forces in the y, forces in the x here. So let's find tension. Then from here we can find force. We can find the tension. So let's make T subject of formula. So we have T equals to mg over cos theta. Now, do we have the theta? We don't know the theta, but we are given information to help us to find this theta here. So the diagram is like this. So here we don't know the theta, but we know here it's 2. Here we are given 50 centimeters, so that means 0.5 meters. So we can find this using sine, so katoa, sine theta. So sine theta equals to opposite over hypotenuse. So we have 0.5 over 2. So that will give you sine theta equals to 0.25. So find the sine inverse of 0.25. Sine inverse of 0.25. So if you do sine inverse of 0.25, the answer is giving us 14.5 degrees. So this is the angle. So you can put it here, and then you have tension equals to mass that we are given. The mass that we are given is 5 kg. So 5 times 9.8 over cos 14.5. So tension equals to, so after you do your calculations, tension is going to give you 50.6 newtons. So this is the first answer, tension. Yeah, so that's how we find tension. Just focus on resolving tension here, and then equate forces in the vertical forces and the horizontal forces. So this is about conical pendulum. You are making a horizontal circle. Yeah, your job is to focus on the bob and resolving the tension in this rope or string or cable, whatever it is, and then you focus the vertical is going to, of course, the horizontal is going to carry the sine theta. Then look at the information that is given. If the angle is not given, then look at the information given. So this is forming like a 90 degree. Yeah, so meaning that this is hypotenuse, adjacent, and the opposite. But the angle is here. You can use sine to find the theta, which is giving you 14.5. So we look at the second question, which is saying find the angular speed of the bob. Find the angular speed of the bob. Find the angular speed of the bob. So to find the angular speed of the bob, from the same two equations that we made, we are going to derive V. So let's see, equate the vertical forces. So we have T equals to, we had mg divided by cos theta, and then in the horizontal forces we have Fc, centripetal force, equals to T sine theta. Now, what is centripetal force? Centripetal force is given by mv square divided by r. Now, mean that where there is Fc, we are going to put this. So, mv square over r equals to T sine theta. Now, we can substitute this first equation into the second equation where there is T. So, mv square over r equals to T. Now, T we have is mg over cos theta times sine theta. So we have mv square over r equals to mg sine theta over cos theta. Now sine theta over cos theta is the same as tan theta. This equals to tan theta. So meaning that mv square over r equals to mg tan theta. Remember, the question is saying find V, the angular speed. Angular speed as the symbol omega, looks like W, and its unit is rad per second. So whatever speed you are going to find, you must always convert it to rad per second. So now we can get rid of the mass, because on this one mass is independent. This equation is independent of mass. So V square over R equals to G tan theta. Remember, theta we found is 14.5. So from here we can find V. Let's make V square subject to the formula. We are going to make V square subject of the formula. We are going to make, so here we are going to cross multiply. So we are going to remain with V square equals to GR tan theta. So meaning that you can square both sides. So we have V equals to the square root of what? GR tan theta. So this is the formula that we are going to use to find the angular speed. Remember, when we have V here, it means the velocity we are going to find is in meters per second. But when we have W omega, it means the value you are going to find is in as units rad per second. So this is angular. Angular has units rad per second. This is linear speed. Linear speed, it has units meters per second. So let's use this formula because we have all the data needed. So now we are going to have V equals to the square root of G. We know that G is 9.8 times R. We are given radius as 50 centimeters. We converted to meters, 0.5 times tan theta, meaning tan 14.5. So after you do your calculation, so after you do your calculation, you are going to have 1.13 meters per second. Now, this is linear speed. The question is find angular speed. So angular speed has units rad per second. So how do you convert from linear to rad per second? Linear to angular, you use this expression. Linear speed equals to angular speed times radius. So now you have your angular speed, which is 1.13, equals to angular, which you are looking for, times radius, which is 0.5. So after you do your calculation, you are going to have 2.26 rads. So meaning you are going to have angular speed equals to 2.26 rad per second. So this is the final answer for the angular speed. We move on to the second question. Let's move on to the second question. The second question is the last question on the question 2, saying find the rotational frequency of the bulb. Find the rotational frequency of the bulb. Find the rotational frequency. Find the rotational frequency. So rotational frequency is given by angular speed divided by 2 pi. Always remember, rotational frequency rotational frequency is given by angular speed. This is angular speed. Make sure that your speed is as units rad per second, and then this is the rad. This is the rad. 2 pi means 360 increase. So this is the distance or angle. It is in rad. So rotational frequency Fr equals to angular speed over 2 pi. So the same angular speed that you found, you are going to divide it by 2 pi. So rotational frequency equals to 2.26 divided by 2 pi. So after you do your calculations, you are going to have 0.36 that's the answer I'm going to have. Yeah, so we are going to have 0.6. So here we add units. So you just units rad per second over rad. This is the units that you have. So you are going to cancel the units. Here I'm just finding the units I'm going to have. So rad, this has unit rad, 2 pi rad. This is 2.26 rad per second. So we can cancel the rad and remain with the second per second. So remember, the best unit of frequency is per second. This is what you have.